This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
For centuries, the trajectory of physics followed a single, continuous search for invariant regularities. From the mechanics of Isaac Newton to the Standard Model, the discipline advanced by identifying laws that govern the physical substrate. This law-centric mode of explanation has reached its architectural limit. A purely physical theory relies entirely on extensional and quantitative primitives. It maps physical states and dynamics, but possesses no internal vocabulary for subjective meaning or the observer. For state-level investors and sovereign wealth funds, this creates a structural bottleneck. Capital allocated strictly to physical substrates, such as standard quantum computing arrays or unified field research, faces the asymptotic wall of diminishing returns. Standard models perfectly describe the dynamical evolution of a signal, but a signal is not a measurement outcome. Defining an outcome requires semantic closure, a classification of identity that physical models structurally presuppose but cannot engineer from within. The equations of standard physics remain operationally correct while the discipline reaches its natural boundary. We are observing an exhaustion of scope. To bypass these diminishing returns, institutional capital allocation must move up the stack. Realizing proprietary control over the stability of physical dynamics requires shifting focus from foundational physical substrates to pre-physical infrastructure. This boundary is defined by Theorem 10.3, the End of Physics Theorem. The theorem establishes that no purely physical theory can achieve ontological completeness. Ontological completeness requires a theory to internally define its own measurement outcomes. It must specify the conditions under which two distinct results are classified as identical, a requirement known as outcome identity. This diagram outlines the structural limit. Outcome identity necessitates a semantic equivalence relation. Because the language of a physical theory is strictly extensional, semantic equivalence is categorically undefinable within it. The physical theory generates dynamic signals, but the process halts at the non-definability barrier. It fails to cross over and reconstruct the semantic closure provided by the observer monad. Physics remains a closed, operationally valid discipline. However, because it is mathematically forbidden from defining its own foundational observer, it represents an incomplete target for state-level technological investment. If physics cannot serve as the base layer of reality, it functions instead as a middle projection layer within a larger framework. We define this relationship through the mathematical operation of projection. Projection is a formal structure forgetting map that erases observer-dependent semantic structure to produce the physical domain. This model re-evaluates the nature of physical laws. We start at the top layer, a rich structure of pre-physical observer coherence and internal semantics. When the projection map is applied, it intentionally discards explicit observer distinctions, projecting the remaining data downward into the physical domain. Physical laws are the emergent relational invariants that survive this forgetting process. Because this projection discards structure, it cannot be reversed. This structural asymmetry enforces the irreversible arrow of time, preventing the physical layer from reconstructing the semantics above it. For sovereign wealth allocators, this means proprietary advantage lies in engineering the coherence fields that cast these invariants, rather than attempting to manipulate the resulting shadows. This theoretical architecture translates into an actionable footprint within the domain of quantum measurement. Standard quantum mechanics assumes that the choice of measurement basis operates as a smooth external parameter, with outcome probabilities varying continuously. This chart shows the operational signature of coherence plateaus. Standard physics expects the smooth, dashed blue curve, where outcome statistics vary continuously with the basis rotation. In the standard prediction, statistics depend smoothly on the orientation of the measurement. The post-physical prediction presents a different data signature, the solid green spectral plateaus. Here, outcome identity is forcefully stabilized by observer coherence, overriding the expected smooth variance. The vertical gray boundaries mark the threshold where coherence breaks. Crossing these lines trigger discrete semantic regime shifts rather than smooth physical transitions. These spectral plateaus constitute a discrete domain of stability. They represent structural leverage points that standard physics cannot access or predict. State-level capital always requires strict scientific diligence. Any target for this tier of investment must be empirically falsifiable. We establish this through Experiment Class I, fractional basis sensitivity. This protocol uses continuous basis rotation in optical or superconducting systems to test for the existence of these discrete coherence plateaus. The falsification criterion is absolute. If continuous basis rotation yields perfectly smooth outcome distributions with no plateau behavior, the post-physical architecture collapses. A secondary falsifier also exists. If an observer model can be canonically reconstructed using only physical functors, refuting the no-right adjunct theorem, the thesis is invalid. By defining these structured failure zones, the framework transitions from a philosophical interpretation into a de-risk target for deep tech capital. The discovery of the spectral plateau reveals more than a measurement anomaly. It exposes the underlying layers required to generate that stability. This stack represents the full engineering paradigm required to harness pre-physical coherence. At the top is Realica geometry. This is the foundational structural reality that dictates the potential for any stable outcome identity. Beneath geometry is the KP field. This field manages the coherence dynamics that prevent measurement outcomes from dissolving into smooth physical variance. The FQFT layer is the mechanism of spectral selection. It is where these upper tiers funnel into the visible plateau of the measurement result. Finally, we reach the bottom layer, physics as projected laws. These hexagons are the terminal invariant shadows cast by the layers above them. Institutional capital achieves proprietary control over the stability of the causal chain by targeting the top 3 layers of this stack, leaving standard physics as a downstream byproduct. Fabrica and the Global Invariant Ledger Corporation, or GILC, are the investment engines designed to execute on this full stack. The Bulgarian national pilot provides the active sovereign deployment of this architecture. The strategic advantage of GILC lies in its governance protocol. It deploys a temporal projection function designed to simulate and enforce systemic stability across deep time horizons. To ensure operational integrity across centuries, the protocol implements a generational structure that passes control from founders to multi-century continuators. State-level capital allocation now targets invariant stability and pre-physical infrastructure over short-term software disruption. Acknowledging the end of physics is the beginning of engineered multi-century civilizational continuity.